the addition part of polynomials, and today we're covering the subtraction. Used to be I did all of this in one day and found out that, you know what, and hopefully yesterday felt really easy. But as soon as I combined the subtraction within the same day, then it just didn't go as well. So we're going to work with subtracting polynomials today, and I am going to highly recommend, if not at some point even requires, if you're getting it wrong, to rewrite as an addition problem. So when we rewrite as an addition problem, we change it to add the opposite. Now, when we talk about changing a subtraction problem to add the opposite when there's a polynomial, we're talking about that the polynomial that is being subtracted, that whole polynomial has to change to its opposite. Not just the first term of it. If it's not just a monomial, if it's a binomial, trinomial, 4 terms or more, we have to talk about, we're going to have to change all of the terms, all of the monomial parts of that polynomial to their opposite. And then we'll just follow our steps for adding. Okay, well, in this first one, we just have a binomial, and we're subtracting from it a monomial. So in reality, there's only one thing to change to add the opposite. So here's what I'm going to suggest we do. We take it as, we leave them as polynomials. In other words, we leave the parentheses there, and we just change the subtraction in between the polynomials to addition, and the monomial parts of the polynomial being subtracted to its opposite. Then we'll do what we did yesterday. When it's addition, you can just drop the parentheses. So we'll just drop those parentheses. And at this point, everything should already be addition. We're not going to have to change at this point. Now we will just combine our like terms. And some of you feel you don't need to do this rearranging step. And if you don't, so be it. But you are going to show me this, getting it ready to making it into an addition problem at least. Okay? So what is our answer for this one?
Negative 2x squared.
Okay, negative 2x squared plus x. Okay. So we first changed it from a subtraction problem to an addition problem. Then we dropped the parentheses, rearranged, added like terms, right? That's when we had a monomial being subtracted. That's how it looks. How's it going to look if we have a binomial being subtracted? Okay. So let's first of all, the first step that I want you to always do, again, I only make these recommendations from what I've seen of students' prior work, other years, and I know what mistakes they make. If we change all subtraction right away inside the polynomials, just inside the polynomials themselves, any subtraction we have, we change it to add the opposite, we tend to be more successful. We meaning the students that I've already experienced this with. Now we're going to do change the subtraction for the polynomials. No, we're not dropping any parentheses yet. Change this subtraction to addition. And now each of those monomial terms have to be changed to their opposite. So we're going to have negative y squared plus negative 7. And typically where the mistake is made here is we only subtract the first term of the second polynomial. And now we can say, okay, now I can drop the parentheses. Well, if now in dropping the parentheses, you want to do your rearranging step at the same time, you could, because everything's addition anyway. I did not. Now I'm just going to rearrange so that my like terms are grouped together. So the rearranging helps us to put it in standard form while we're rearranging. The blue step is the rearranging step. Put the like terms together, order them from the highest degree to the lowest degree, the terms, and then combine any like terms that you can and clean up your answer. So what do we have here? 8y squared plus 3y, there's nothing for those y's to be combined with, plus a negative 7 is the same as minus 7. Clean it up at the same time. So we end up with 8y squared plus 3y minus 7.
Plus 3y should be minus 2. You forgot to bring the negative.
Oh, I did forget to bring the negative down, thank you. Okay, so that's plus a negative 3y here, so then that's with negative 3y. So yes, this will become, let's have an eraser now. This will become a subtraction here. Yeah, we would not have wanted to leave it like that. Okay. Any other mistakes? Don't want to leave it as it's not supposed to be. Good catch. 8y squared minus 3y minus 7. Okay, let's move on to the last one that we're going to practice on this side. What's the first thing we're going to do before we even deal with the fact that there's subtraction of polynomials? Courtney?
Add the opposite.
Add the opposite inside the parentheses. So we're going to make it an addition, the polynomials themselves addition problems. We're not going to mess with that subtraction sign in between yet. Just leave it. Don't be in a hurry. Take care of the polynomials themselves first. If you try to do both at the same time, it might get you in trouble. So just take care of any subtraction inside the polynomials themselves. So do we have that right? Or do I have that right? Okay, now we're going to change only the second polynomial. The first one doesn't change. Whenever we change to add the opposite, we don't change the first one. We change what is being subtracted to its opposite. So our polynomial now, every one of those is going to change to its opposite. So we're going to have a negative 5m to the 4th. Opposite of a negative 5 is a positive 5, so that's going to be a plus 5m squared. And the opposite of 8, negative 8, is positive 8. So when you look at it, you should be able to see everything in the second polynomial is the opposite of what it was before. And now we're ready to ditch those parentheses and rearrange. Let's do all that in one step. Okay, what would be first in this in standard form?
7 and 4. To the 4th.
The, is it a oh, this would be to the 4th power. I missed that again. Oh my goodness. Okay, 7m to the 4th power. And so we're going to bring that, let's have the m to the 4th powers get placed first in our rearranging. Okay, what would be next? The m squares. So we have a negative 2m squared plus 5m squared. We have 5 terms altogether. We gotta have 5 terms now too. And we need a plus 8 yet, right? Okay. So how many m's to the 4th do we have? 2. Anybody catch themselves accidentally making m to the 4th plus m to the 4th, m to the 8th in your homework for today? Sometimes it's an easy mistake to make. And then, how many m squares do we have? 3. And then that's our 8. So a problem that in the beginning had a whole lot of subtraction going on is now all addition, all positive numbers. That's a 4 there. Okay, any questions, concerns? Places that something doesn't quite make sense. Don't try and shortcut subtraction, so you're really, really ready. I can do a subtraction problem without showing any of this, and you maybe can already, but make sure that you can before you try to shortcut it too much, okay? Okay, let's go to the back side where we're gonna do some application problems. Okay, read through number 4 to yourself and decide what you think you gotta do. So Jared, what do you think we should do? What do you think we have to do in this problem?
Write a polynomial for the total volume of 2 boxes.
How are we gonna do that? How are we gonna go about that? How are we gonna start?
4x cubed plus 4x squared minus 6x cubed minus 18x squared.
Okay, so it's not writing it fast enough for me, so here, let's see. So I think I heard this, 4x cubed plus 4x squared, and then what was the next thing?
Minus 6x cubed minus 18x squared.
So we're gonna subtract the second polynomial from the first one?
Yep.
Oh, I got some head shakers in here, they're not agreeing with you, Jared.
It's the total.
Let's write a polynomial for the total volume. What is the first polynomial representing? Volume of the first box. What's the second polynomial representing?
Second box.
Volume of the second box. If we want a total, should we subtract?
No.
No, we need to add. Okay, so let's make this into an addition problem. Now go ahead and do the work you need to do and get the volume of the total volume of these 2 boxes. When you're done, you can see if you agree with me or if you need to challenge me on any part of it. I'm not saying I'm totally done yet, but this is how far I am. How do you feel about my answer? Or your answer? Thumbs up? Okay. What can I do with this yet? Let's simplify to clean it up at least, yeah? Because I can't simplify it, I can't put those 2 terms together, can I? Are they, no, so I have 10x cubed minus 14x squared. Okay, now, we always put a label on our application problems because we know what what this is representing. So what is this representing? Cubic units. Now here's what we have to do though. If we just write cubic units behind it right now like this, we go, or units cubed, like this. What might somebody think? Any idea? Abby?
You might think that the polynomial is taken to the 3rd power.
Okay, well, that's a possibility. But even if it was, there was some polynomial taken to the 3rd power and you were finding volume, would that be okay? You know? It really just has to do with how the label is attached to this answer. What is the answer? In other words, is it just the 14x squared that's being subtracted that are cubic units? No, what is it? It's the whole polynomial, 10x cubed. So what do you suppose we should do with it? And hopefully after doing your SQ3R, that should have been what happened in the lesson. So the polynomial 10x cubed minus 14x squared is cubic units or units cubed, okay? So we want to put our, whenever our answer becomes a polynomial answer, put that in parentheses and then the label behind it, okay? Okay, let's take a look. Go ahead and read through number 2 and decide what we got to do in number 2. Maybe right now we should decide what's the first thing we got to do in number 2. Okay, suggestions? Courtney?
Polynomial.
Okay, write the polynomial that represents perimeter. Okay, how do we find perimeter of a rectangle? Jacob?
2L times 2W
2L times 2W plus?
plus.
Isn't perimeter adding up all the sides? So I think we probably want to add 2 lengths to 2 widths instead of multiply, right? Okay, so 2L plus 2W. Well, basically then we should be able to just substitute what they told us the length is into that expression, right? Okay, so we should be able to do 2 times what? 15x.
X.
Don't leave that x out. They say the length of the field is 15x yards. And then we should be able to substitute in for W. Okay, so length of 15x, width of 10x minus 3. We'll get some simplifying to do. We have to do some multiplying, right? 2 times 15x,
30x.
30x. Let's change this to add the opposite, and we have 20x plus negative 6. Is that right? Are we done? No. We can simplify that. Yeah, so we will. What do we have? 50x. Those can be combined. Plus a negative 6 would be
Minus 6.
minus 6. Okay? Now, again, this is representing perimeter, right? So anybody know what we would label that?
Yards cubed.
Yards
I mean-
cubed?
Squared.
Yards squared. Oh my goodness, we have so many choices. What are we going to decide? Yards, yards squared, yards cubed. Which one is it? Oh, just yards. All in favor, just yards. Yards squared. Yards cubed. Oh, I know, there were so many hands went up for yards and all the rest of you that said, we're saying those other things, saying, I should rethink this. Okay, then convince us why it should be yards then. Why should it be yards? Todd?
Because perimeter is an area of yards squared and
Todd says very quietly up here, perimeter would be yards, area would be yards squared, and volume would be yards cubed. Why? Because that's what you learned somewhere along the line, or?
perimeter, you're not multiplying any yards by it, you're just adding.
Oh, he says when it's perimeter, you're not multiplying any yards by yards, you're just adding up yards. Yards added to yards, added to yards, added to yards, right? When it's area, what do?
Multiplying yards.
You multiply length times width, so you're taking yards times yards, which becomes
Yards squared.
yards squared. And what happens with volume?
Length times height times
It's length times width times height, it's 3-dimensional. So you take yards times yards times yards, and you get yards cubed. There are a lot of us who need to get this planted in our brains. Why is it that way? Some of us just wing it, and we're like, oh, I think it's yards squared, I'll just put that. Anybody get a point taken off of their last quiz because you had the wrong label? Yeah, we did. So we have to know how to label these. Okay, so then we're gonna put yards. Is that the way we're gonna do it?
You have to put that in parentheses.
You have to put this in parentheses. It isn't just 6 yards. It isn't 50x, take away 6 yards. It's 50x, take away 6. That whole expression is yards. So here's our perimeter, right here. And then it says, calculate the perimeter if x equals 2. Well, that should be easy enough, right? What do? So we put 2 in for
X.
x. So we put 50 times 2 minus 6. So it's, come on, people haven't been using your calculator like you do this. 100, take away 6, so it's 94 yards. Do we need parentheses around that 94? Pardon? No, that's a monomial. We don't need to put any. We have our total perimeter if x is equal to 2, or when x is equal to 2. Okay, so any questions on that one? Okay, take some time reading the next one and processing and labeling and doing whatever you need to do to figure out what in the world are we going to do in number 6. Any suggestions? Jacob?
You could take 12x squared minus 7x plus 5 minus 9x plus 1 minus 3x squared plus 4.
So, because we need to subtract,
It's the distance from the.
so could we do some labeling on here? If they measure these cabins, could they just measure randomly and say, okay, we're gonna measure from the back side of one cabin to the front side of the other? Or what would they have to do?
Have to measure in units.
They'd have to measure from the same spots, basically, so if we measure from roof to roof, maybe, I'm not sure anybody got up on the roof to do that, but let's make it there, from there to there. What is the polynomial for that? Oh, it's 12x squared minus 7x plus 5. And then the distance from one cabin from the river and the other cabin from the river, now we're talking about, oh, from here to here and from here to here, right? So for this one, we have, let's give that one the, 3x squared plus 4. No, 9x plus 1, let's make that one. So that's a 9x plus 1 there. And then this one, we're going to say is the 3x squared plus 4. And what we're looking for is this right here, aren't we? From there to there. So if we have the red, on mine anyway, the red distance, take away the 2 green distances, should that leave the blue distance? The width of the river? Shouldn't it? Okay, well, so then here was Jacob's setup, and you can make your own setup if you don't like his. I think this is what he did. He said, I'm going to take the total distance, and I'm going to subtract from that the other 2 distances that the cabins are away, and that should give me the distance across the river, the width of the river. You all agree? Is there another way we could go about that? I think we still have to do subtraction, but is there another way we could do that to maybe eliminate a couple of subtractions? Well, if that's gonna be our process, add the opposite, but what, staying on the idea of adding. Abby? What do you think?
Well, I had a different setup.
Okay, what was your setup, Abby?
I had the same thing to start, then
Okay,
I subtracted, and then added brackets, and then 9x plus 1 in parentheses, and then I added that to the other column.
so like that.
Yeah.
So could we add those two distances and then subtract that from the total distance? Yeah, it could work either way, couldn't it? Okay, go ahead and make this happen. Find out what is the distance across the river. You pick which way you want to do it, it's your call. I'm not saying I'm right, I need you to check me out if you agree. I need the polynomial x squared minus 16x to represent the width of that river. I get the polynomial, that's right, parentheses, and what would its label be? Feet. So I did add the two together first and then do the subtraction. If you did the two subtractions, Jacob, did you do it your way? You ended up doing it Abby's way?
That seemed a lot simpler.
Okay, anybody do the two subtractions? We'll make sure we get the same answer. Braden, and you got the same answer as we did? Cool. Okay. So are we going to agree on this before we evaluate it with x equal to 3? And we agree on this.
Like resquared went into the red and changed the plus 4 at the very end to plus 1.
Okay, but that would be, here's why I did.
Oh, yeah.
Right here, this is when I was combining like terms in that next step, okay? And then, so then that was just combining like terms, and then I changed to addition, and every one of these had to change to their opposites from the previous step, right? Okay, so now that we think we decided we can agree, I'm not sure, but 9x squared minus 16x, we put 3 in for x. And actually, since that is not a negative number, I can just put it in like that. And then I would do 9 times 9, and that's 48. And that's 81. And I believe that should be not 43, but 33, right? Don't just copy me, do it yourself and make sure you agree with me, because I make mistakes, I'm human. I've been known to make silly mistakes on tests, just like happens to you. So do you agree with me? All is well? Okay, so, any questions, concerns? Adding, subtracting, polynomials. Got it? Okay.